Title AI Power Smart Cost Estimation for Construction Planning. We are Team 16. I am Likita and my team members are.
Hi, I'm Akanksha.
Hi, I'm Kiran.
This is Gautam.
Hi, I'm Diana.
Yeah, today we will take you through how we use AI machine learning to tackle major problems faced in the construction industry in cost estimation. The pro the flow of this presentation would be like in it starts with introduction, literature review, project overview, system architecture, and followed by the demo and conclusion. The what is this problem is about? Accurate cost estimation is the backbone of the successful construction projects. Yet, in reality, and traditional methods often fall short and face problems like incomplete data, sudden market changes, and human biases, or any intermediate errors. These challenges are frequently led to delay of projects and major cost overruns, affecting both timelines and budgets. Recognizing the issues we asked, can artificial intelligence provide a smart solutions, faster and more reliable way to estimate construction costs? And the question of our project is set to answer those questions. Our solution is a hybrid system combining machine learning LLM models, which result in random forest regression trained on real world construction data to predict project costs, and integrated with GPT-4 to offer dynamic insights in real time through easy and streamlit. Literature review would be. But before we explain how we design the system, let's first understand why traditional cost estimations struggles and how recent research groups using AI LLMs are smarter in the planning. Traditional cost estimation methods, as outlined by the researchers like Orena in 2006, heavily depend on expert judgment instead of the how. However, they often suffer from limited historical data and cannot quickly adjust or judge the unpredictable market ranges. Manual estimation also tends to slow down the prone bias, which increases the chances for cost overruns and project delays. Research and one such other example is research by Zahar in 2013 how artificial intelligence, especially machine learning, offers a way forward. AI models can analyze large datasets, detect hidden trends, and generate faster or more reliable predictions compared to the traditional human methods. Building on the advantages of LLMs like GPT-3 and GPT-4, as shown in the studies like Brown into done by, in 2020, demonstrate the power of AI to synthesize knowledge and deliver intelligent and contextual insights. In construction, this means better forecasting and smarter planning and faster decision making. Earlier AI-based systems, those proposed in 1996, estimated cost forecasting, but were limited in dynamic and real-time interaction. Combining the combining structured machine models with AI creates far more powerful decision support system. With these insights, With these insights in our mind, our project brings together predictive analysis and contra- conversational AI to offer next generation construction cost. Our, my teammate will continue how with the project will proceed.
Yeah, our project is basically estimation of cost for a construction for planning a house or any project. So it is basically an AI and machine learning system for estimation. So first we have built a Streamlit based web application where we use input details like type, location, area, number of floors, and the basements. So using machine learning, that is, we have used random forest method. The system predicts the estimated cost, construction cost. So along with the random forest, we have also integrated OpenAI's GPT-4 to LangChain to provide professional advice, simulate project changes, and also estimate cost impact in a single conversational way. So this app basically also includes EDA dashboard, that is exploratory data analysis dashboard, that visualizes the project data trends, helps the user understand better location based on project behaviors. So overall, this project combines the power of ML with like human-like consulting to support smarter construction management. So basically, human tends to do many errors, but I think our project has ML touch to rectify the errors. Now, system architecture is continued by Gautam.
Yeah, coming to system architecture, it connects a streamlit web app to a random forest regressor for cost prediction and a GPT for LLM for conversational support, both using historical construction project data and real-time user inputs. The methodology involved data pre-processing, like handling missing values and outlier detection, label encoding for the converting all the categorical data to the numerical format, training a random forest model to predict total construction costs based on parameters like area and floors, integrating GPT-4 via LangChain for natural interactions, and building an interactive streamlit interface that includes cost estimation forms, what if scenario simulations, and then EDA dashboard for better project insights. So basically here, can you go back to previous slide? Yeah, back. Architecture. Yes, it's all architecture. So here we are using a user interface Streamlit web app. So which is an alternate, like which replaces both HTML. We don't need HTML and CSS files code for developing a user interface. In machine until a machine learning model execution, we don't need any API call, but to interact the machine learning output with an OpenAI model, we are trying to make a call using API. So it generates a call to the GPT-4 server. So based on the custom question that we generated from the ML model, it will uh, generate a natural language answer for the question that was asked by the customer. That's all about system architecture and methodologies that we have used. Okay, I'm gonna continue on the implementation path. Like as Gautam said, we have done the data quality check. We have checked for null values, and we have detected the outliers if there are any. And for like machine learning model, we have used the random forest. And then we have also included one what if simulator, which will dynamically adjust the cost estimation based on the changes that we give, like if you increase the floor, or if you increase the basement, or if you change the location, accordingly it will give you a cost estimation. So let me go through the code. We'll walk you through the code. Yeah. So we have used Visual Studio platform to implement our code. So we have first written one .py file, a Python file. We have imported all the important libraries which are required for our program, like the pandas, matplotlib for the EDA dashboard, and then we have included the OpenAI libraries as well. So we have included one memory for our OpenAI, so that it would be stored, and we can clear the cache for the new conversations. And we have included our data set. We have loaded the data set, and we have gone through the pre-processing steps, like detecting the missing values. And if there are any outliers, we try to rectify them. And yeah, as Gautam mentioned, we have used the Streamlit process for our user interface. We have designed the user interface using the Streamlit, which will integrate all the, which will replace usually the HTML and the CSV file. And we have included all our API keys into an environment, that is V environment, and we have included all the important libraries in requirements text file. And after running this file using the terminal here, PowerShell, it will redirect to this screen. So it's a local host here. So if you want to see, if you want to go through our data set, that's going to be like this. So we have like columns, material cost, labor cost,
and the total estimation. And there are like various types of our project: industrial, institutional, commercial, and residential, of course. And we have like area covered, and depending on the flows, the project estimation would vary, and also depending on the location, it would vary. Like the New York and San Francisco being the uh, more higher prices, and Houston were like economy. And as we see, if we do the data quality check, there were no missing values in our data set, and we were having like 11 outliers which we have uh, detected, and then we have solved using the z-score. And after the processing the dataset, our dataset would look like this. And we have also included some of our like exploratory data analysis dashboard, which will give you an overview of our data set, like which are the main components that we have and how they are linked to each other using a correlation heat map. You can see all these like the material cost is what more correlated with the total estimation and also total area. And also so these are the two major factors that would affect our project cost estimation. And yeah, you can see the trends of our total cost to the locations, like here San Francisco being the highest, and the Los Angeles follows, and Houston and Dallas are in almost same range. So these are the options that you would see in the screen. Like if you can select, there's a drop down here, like you can select residential, commercial, or industrial, whatever, whichever project you are choosing to. And if you select like New York, and if you can type your total area here, like for example, I have included like 89 meters square, and let's take like 2 floors, and basement, let's give it as 1 for parking. If you like click on estimate cost, it will give you an estimated cost, like how much it's gonna be. Like it's gonna be like 6 lakhs dollars around. And if you we can change the location here as well. That will change, like let's take Houston. If you change the Houston, then that's gonna be lower than that, as we are. Yeah, compared to New York, it is very low, like 484 lakh dollars. And you can change that here as well. Like we have, you can add 4 more floors to the plan so that it will change accordingly. The obviously it has to be more than 483, so it's like 494, as we have added 4 more floors. And it will also give you an explanation on how it has changed and what factors affected the price to get high. Like you can see the cost of the project increased due to addition of 4 new floors. Like building additional floors involves several factors that contribute to the overall cost. These include the cost, materials, and so depending on all these factors, so it has also given professional advice which are needed for the project. And of course, and there is one more box. You can see that you can ask any question to the chatbot so that it will give you an appropriate or nearby answer. Like what are the permissions required for this project or for this construction, you can mention. So it will give you an overview of what are the permissions that has to be taken for this construction to be done.
You mean for the project approval?
Yes, like the project approval and all, it's still running. Yeah. So for this construction, we need like planning permission and building regulations, approvals, and environmental regulations, land use permit. Yeah, of course, all these health and safety permissions. So this is a generative AI answer, and also this will change accordingly if you give any ad flows or increase the area by 20%. Whatever you can give it, it will change, and it will give an estimation of the cost. So this is about our project, and the next slides would be continued by Diana. Yeah. So we have included the screenshots as well in the presentation slides that we just gone through. I'll just quickly walk through them. Yeah. All stage is yours, Diana.
So coming to the conclusion part, our project demonstrated the potential of combining artificial intelligence and machine learning for smart construction cost estimation. So we successfully developed a hybrid system where the machine learning model, a random forest regression, accurately predicts construction cost based on technical parameters like area, floors, and project type. Meanwhile, the integration of a large language model, GPT-4, enhance the user experience by enabling natural conversational interaction and professional project advice. So, our approach not only improves the accuracy and efficiency of cost forecasting, but also empowers construction managers with intelligent decision support, minimizing risk and planning delays. So overall, this project showcases how emerging AI technologies can revolutionize traditional construction management practices. So coming to the future work, we plan to fine-tune our random forest model by incorporating more extensive and diverse real-world construction data sets and to make our cost estimation even more realistic and useful, we propose integrating real-time market data for material and labor costs. And we envision on expanding the AI chatbot's capabilities to not only provide cost estimates, but also recommend cost-effective material alternatives such as design optimizations and guide users through the permitting and regulatory process involved in the construction. So this is the overall project. Thank you.
So that concludes our presentation. Thank you for listening. Thank you all.
Thank you.